So it seems like we're ready to launch into class life. Oh, don't forget your AP order deadline is coming up. Yeah, what?
So just to clarify, there's no post lab due tomorrow?
Correct. Yesterday, did we make ozone in the atmosphere?
Yeah.
Yes? And did we talk about how it is naturally eroded by ultraviolet light also?
Yeah.
And did we talk about how humans contribute to the depletion of ozone? Okay. So,
We were getting into that.
great. At this point, I need to stress a few unfortunate issues before I get started. First of all, there's like an infinite number of man-made gases that break up ozone. You need to know the most common ones. They're here: chlorofluorocarbons, hydrochlorofluorocarbons, halogens, methyl bromide, carbon tetrachloride. Those are the most common ones. But the key definition, the thing that you really got to remember, please look up, is ozone depleting substances are fundamentally anything that spits off that yields single chlorines and single bromines. Everybody got that?
One more time.
Ozone depleting substances are any compound that can give up a single chlorine or a single bromine.
Is that because the chlorine or bromine grabs an oxygen?
Yeah, precisely. Does anybody remember the 3 rules of ozone chemistry we did yesterday? Number 1. That's right. The atmosphere is very complicated, and we're making it more complicated. We've added new stuff. Number 2, ozone rule.
Anywhere in the atmosphere is oxygen.
That's right. You can just throw oxygen around anytime you want because we're talking about the atmosphere, so oxygen's all up in there. And ozone chemistry fact number 3, Hufbrinkel. Very, very good. Hufbrinkel are those diatomic elements that just cannot exist on their own for very long. We all agree with this? Everybody's on my page here? Now, I'm going to need 7 volunteers. Let's do it. 7 volunteers. Come on. Come on. Be my volunteers. I need 7. Come on. I need 6, 5, 4 volunteers, please. Come on. I need more volunteers. Come on. Couple more. It's not that bad. Come on. More volunteers. That's okay. We can take more.
No, it's good.
You get the easy job. You can just sit there.
The AT&T line.
Quit staring at my burrito. It makes me uncomfortable.
I steal one.
I have more than a source of food. Okay. Ozone up. Ozone up. Ozone up. Ozone up.
Do we hold hands?
Yes, ozone. There we go. Okay. I have my hands. So, remember that these hand holdings and relationship metaphors just represent bonds. So we have O3 and O3, and me I will be some ozone depleting substance. Me and this cart are like chlorofluorocarbon because somebody just spray painted on a wall. Or me and this cart are methyl bromide because somebody just needed to fumigate a strawberry field. Or me and this cart are hydrochlorofluorocarbons because there was a car accident and somebody's freon is leaking into the air. Do we agree? And for the sake of conversation, I will be chlorine, but this could be any Hofbrinkel. So let's say that this is chlorofluorocarbon, okay, CFC. I get zapped by ultraviolet. So now I'm a clingy single. And what do you know about a single chlorine? What will be my behavior? What do you know about my activity? I will latch on.
Oh my god.
See, now I'm cool. Now I'm cool. Goodbye. I ripped off an oxygen from ozone because my clinginess was stronger than their bond strength. So I got me an oxygen. And I am basically satisfied for now. You could say I'm a home wrecker for ozone. There's a problem. This isn't going to last very long at all. You know,
You don't cry.
oxygen, fundamentally racist. Jackie's thinking to herself, you know, I can do better. Jackie's thinking, you know, as soon as I find some single oxygen, I'm going to jump ship. She's already planning her departure. So as soon as there's a single oxygen around,
Oh god.
they will make a more firm relationship because oxygen belongs with oxygen. This is really what Jackie was hoping for.
Yes.
And sadly, I'm back to being desperate and single. My need is not strong enough to break their bond. I did, because you know that threesome was always kind of wobbly in the first place. That's right. These are diatomic gases by definition. Remember that I'm using all these metaphors to explain bonding. So remember, that bond is stronger than my need. I can't pull as much as she holds on, so to speak. Everybody got this? So here's me being single. Come on, go on. No. Aha! Got one. You'll notice I've ruined more lives back there. But remember, fundamental fact, this is a B-rate relationship. This is like love in prison. Good enough, but not really. Temporary. As soon as there's another single oxygen around, I go back to being needy. And I'm like, oh God, there's just, what am I going to do? I can't break any of these. So I will keep eating up ozone. You can see it.
Really, really old.
Aha! I can go! Yeah! Got one! But of course, remember, like I said, one of those rules of ozone chemistry is that there's always oxygen around. So this is only going to last until Carlton finds vape. I go back to grade 6, all the PD again. The first thing I want you to remember here is that one single chlorine atom can tear up the entire ozone volume of this classroom in seconds. Graham. In seconds, all the ozone of this classroom would be dissolved by one atom of chlorine. And look, if all of you were ozone, I would keep tearing you up. I would keep tearing you up until what could finally stop this vicious cycle for good?
If find someone to bond with.
True love.
SB President.
You see, if I find another chlorine, for example, I'm done. I don't need to mess around with all of your racist oxygens anymore. I know where your love lies. Some people just really like the whole head. That's cool. That's really cool. I'm really love this. You think. Some people love hand sweat. Look. Think of anthropogenic ozone depletion as an act of desperation. When I find the bond that I really have been dreaming of, I'm not going to mess around with any more of that ozone in there. You know, you could say that the homewrecker has found true love. And now ozone is safe to form again. You can all go back to making threes really quick. Because, you know, ultraviolet will split up a few and then they make threes. And look, they're cool. When we walk by, we're like, we know what we really wanted. Remember that the ozone depletion issue is me being clingy, because if I'm clingy, then I just will tear up the ozone. But this won't last very long because oxygen is racist. So I will keep tearing up ozone. Everybody got this? Go sit down, kid. Thank you. Good job. Okay, so, yeah.
So the reason for climate increases is just so on the bad side right now, not necessarily.
You tangled your words. I think you said climate.
There's oxygen attached after the second oxygen attached. So like when the chlorine attached to the oxygen and then they broke off to another oxygen, it's not ozone until the oxygen attached to it. Yeah. So how long does that take for the quick process?
So,
Chlorine is frozen seconds.
wait, say it again.
So it's like there's only two oxygens, so that's not ozone. So it's
That's
just two.
oxygen gas.
Right.
And that'll probably remain oxygen gas for a long time.
So, okay, so how did the ozone come back and being broken up from?
Because everyone is ultraviolet C, ozone is being made in small amounts. Yeah.
So then, if we like not could control this, but if we released
Yeah.
any of the diatomic elements only in pairs,
Yeah.
then there would be no problem at all.
Right.
So it's only the chemicals that are able to throw off
That's
one
right.
of the diatomic elements.
That's right.
But you said earlier, like bromine or it's any of the seven. It's not just two that you named at the same time.
It is primarily those for separate stoichio, gravity, density. I'll keep that on there. Okay, so a bunch of little tidbits for you. First of all, let's go back to me and my cart. I'm a man-made chemical. You know one way that you can regulate ozone depletion? Just force people to make stronger compounds. You know what I mean? If you could please look up. This is the most common fluorocarbon, Cl3Fc. Everybody sees that? Cl123Fc. Cl3Fc. Everybody sees it? Okay. ClClClFc. Fundamentally, this is useful to humans because this performs some industrial chemistry benefit. Flip side is, one of those is inherently weak. That's the cart, that's Jose. This one. So imagine, if I have Cl3Fc, the problem is not necessarily the chemical per se, but the weakness of that bond. Because now I can be the home wrecker, right? So what William was saying is, if we only emitted Hofbrinkels in couples, there would be no ozone depletion. Does that make sense to everybody? Like, if Belfiore and I entered the atmosphere already as Cl2, we're not going to hurt anybody. It's not like chlorine gas is bad. It's the chlorine singles. So one of the ways that we've addressed ozone depletion is to make chemicals which hold on to these better.
Could we release chemicals that like grab in the single Hofbrinkels?
Right. That's right. We could also, yeah. For example, like this. These are called distractors. It's like, I'll take oxygen, but I'd be fine just sitting down looking at a magazine. If you got something good to read, I'll just go kick back. Something to distract me. That could also work. Gavin asked a very good question. He says, we were most reckless with the atmosphere 20 or 30 years ago. If we are now more careful with the atmosphere, will ozone eventually recover? And the answer is yes. You remember how once I left the scene, these O2s became O3 again? That's a spontaneous process in the atmosphere. If you've got ultraviolet C, oxygen gas makes ozone on its own. So by removing the home wrecker from the scene, ozone is safe and it recovers and it comes back. You know, this is one of the few environmental issues that we have quashed. Back in the 1980s, we had this very unusual thing called international cooperation. It's spelled I-N-T. In the 1980s, everybody was like, oh wow, you mean pollution is going to cause problems? Why don't we just not make that pollution? And all the countries looked around and were like, is that important for you too? Yeah, you don't like pollution? Okay, great, yeah, sounds good. And they shook hands, and almost all of these, please look up, almost all of these began to be regulated. Most CFCs are now very difficult to use, very limited. Methyl bromide has been phased out almost everywhere in the world except Santa Barbara County. PT dubs, strawberry industry. These are harder and harder and harder to make and harder to ship and harder to sell. So we're phasing out most of these. In the 1980s, people were like, hey, wait, you mean I could just call another country and we could like agree about stuff and solve problems? What a novel idea. And it worked. So ozone depletion is going down. As ozone depletion goes down, more and more of the ozone is filling in. And the ozone layer is basically reforming. Yeah.
The temperature's still going up, so it has to be something other than that.
Will you quit talking about climate when we're trying to talk about ozone?
We're still raising temperatures, right?
This has nothing to do with climate.
Okay.
Yeah.
The ozone hole is getting better?
Yeah. Yeah. As a matter of fact, ozone density in the patch is about double what it was during the peak of ozone depletion. We're about 50% recovered already.
How long would it take to be like?
In your lifetime, up until 2 weeks ago, I was going to say that before you have grandkids, you'll probably have a healthy ozone layer. 2 weeks ago, we found out that there's now a new group of ozone-depleting substances that we thought were not. We thought we had regulated 4 gases that seem to be going up in number. So mysteriously, there are countries that are somehow emitting more ozone depleters than we thought they were.
Yeah, they like it well,
It's not clear to my knowledge. I haven't read the article yet. I know it came out in the journal Nature Geoscience. If somebody wants to look it up, I think it was the March 10 issue. And if you can give me information on this, I'd give you an extra credit point. Nature Geoscience, early March. The article was titled 4 New Greenhouse Gases. No, 4 New Ozone Depleting Gases. Yeah, it's called 4 New Gases Will Contribute to the Destruction of the Ozone Layer.
Give us extra credit if you find it.
I know you can find it. I mean, if you can help me understand the article, give me a good review of it. Would anybody like to talk more about ozone depletion because of man-made gases? If not, there's just a couple of study goals I would quickly like to skim. One more that has chemistry, and then we're done with this assignment. Yeah?
If O2 bonds are stronger than ozone bonds, why does the separation of oxygen create ozone?
Because those singles are desperate and clingy, and if they can't find each other, then they will make ozone. Remember how I said chlorine and oxygen don't bond very well? It's just a way to, like prison love, to keep you sort of meeting some needs. That's ozone too. That single oxygen was like, I gotta find something. So that single oxygen will jump onto oxygen gas because it's better than being single. But, you know, that third wheel's not really wanted. Nobody wants a third wheel in a nice match relationship. Okay, if there are no other questions, I should warn you, study goal 43 is kind of tricky. This all starts with a mystery. In the 1980s, mysteriously, people noticed that the hole in the ozone layer would grow part of the year and shrink the rest of the year. In summer, the ozone hole would almost disappear, and in winter, the ozone hole would spread and grow. What? For a few years, nobody could explain it, and then people did some chemistry in the atmosphere, and they discovered this. This explanation's a little bit tricky, so I want to give you a heads up that this is sort of like, you know, high-level thinking, just so you know. A lot of details will be coming together. We're going to bring together 3 different parts of the unit so far, so it really helps if you will remember stuff from before. You got to be on your A game. Number 1, there are 6 cells. At the equator, do they go up or down? Up. At the 30s, do they go up or down? At the 60s, do they go up or down? So at the poles, do they go up or down? Everybody stop and think about it. Now say it.
Down.
Down. You get what's called a polar vortex, which is a high altitude downdraft. Watch me. At the 60s, those are all going up, and they all meet at one place. The poles, North Pole or South Pole. Technically, I'm choosing to explain this in the north, but it's a much bigger issue in the south. Just so you know, I figured you'd be more comfortable with seeing your hemisphere on top.
Thanks.
Please look up. At 60 degrees, there's a pretty big donut wrapping around the planet. That donut at 60 degrees will all come back down in one place. So while there's not a very dramatic updraft, you can't stand there and feel the upward wind at 60 degrees. You do feel the opposite of all those forces at one point, at the North Pole. And this technically moves around over hundreds of square miles, okay? But at the north of the planet, that downdraft is very powerful. It's significant. You can find a place in the poles where there's literally wind blowing down on top of your head. So a polar vortex. Okay with that? In the summer, let's start at the bottom here. In the summer, it's sunny, so ice does not form in that downdraft. And do you guys all remember that we talked about what do you call it? Acid rain, and I told you that acid hail is possible and acid snow is possible. Do you remember that? In the summer, the air is clear, there's no water making crystals, so in the summer, there's NOx in the atmosphere that distracts chlorine. Like when William distracted me from breaking up more ozone. But in the winter, please look up, you get these high clouds. They're called stratospheric polar clouds or polar stratospheric clouds. Those are really cold because there's no sunlight. They form ice crystals. And in those ice crystals, water bonds with NOx to make nitric acid. And that leaves all the chlorine to run amok and eat the ozone. You see, NOx in the atmosphere works like a bodyguard for ozone because it distracts the chlorine. But when that NOx forms ice crystals and falls down in the winter, then the chlorine is left alone to wreck the ozone.
So in the summer, that's happens.
In the summer, you don't get those clouds, so the NOx is not bonded to water. Okay? Because of the sunlight, NOx and water do not bond. So that NOx does this. It ties up the chlorine. And thus, ozone can spread. In the winter, you get those high clouds. NOx and water combine, so the chlorine does what I was doing up in the front of the class today.
But NOx is a match for chlorine.
Yeah, it is. I'm not sure how that compares to other bond strengths, but it's good enough to distract chlorine in the presence of ozone, yeah. I know it's scary because that's like a whole bunch of variables, but you can do this. Let me make sure that you got all the details. NOx bonds with water to make nitric acid. You know that. That's one of the things that happens in smog and stuff. Also, there's these wheels, and the one at the poles spin downward. You got that. And you know that in the polar summer, it's pretty sunny up there. And in the polar winter, it's no sun, very, very cold. So in the polar winter, you get these high stratospheric clouds full of ice crystals, and those ice crystals steal the NOx and get sucked down by the vortex down to the Earth. So in the winter, NOx crystals leave the chlorine to eat the ozone. In the winter, NOx crystals leave the chlorine to eat the ozone. In summer, with the absence of the clouds, NOx distracts the chlorine, allowing the ozone to recover. Hannah and William?
Do they get sucked down because of gravity because like they're heavier, or just no?
They're crystals, so I'm guessing it's gravity, but I've heard it's got something to do with that vortex issue too. I don't know what the exact relationship is, whether they're sucked down more by gravity or more by downdraft. I don't know. William?
But yeah, after the, like, so when the nitric acid or whatever, like, forms and the chlorine runs wild, is there like a massacre of ozone for like 2 days until all the chlorine like finds other chlorine, or does it last for a long time?
I think it's an ongoing process.
Shouldn't they all match up like pretty quick?
Yeah, I think that the relative abundance of these, like the likelihood of chlorine finding chlorine is extremely low compared to the likelihood of finding oxygen. That layer of the atmosphere is probably very high double digits ozone. So almost everything chlorine will see is ozone, not chlorine. Yeah.
Can this happen in other places too? Like not
Dude,
just
what do you do all day? Take long dumps? Roam the earth?
All day.
Roam the earth? What did occur? That's been like 40 minutes. What was that?
No, I don't know.
I'm not asking anymore. What was that, dude?
Can this happen in other places besides the North Pole?
Can this happen in other places besides the North Pole? It's not common that you get clouds in the stratosphere. This is especially an issue at the poles. And by the way, like I said earlier, this is more an issue at the South Pole than the North. I just chose the Northern Hemisphere because we're in the Northern Hemisphere.
Wait, so these clouds are currently stratified?
Yes, these are high altitude clouds. Correct.
Where does the NOx come from?
It's both naturally occurring and bonus. Some comes from human activity too.
So then, like, the human activity just gets pulled up there because of the flowing vortex?
Because of those conveyor currents, yeah. So coincidentally, this is probably why the Northern Hemisphere doesn't have as much ozone hole as the Southern Hemisphere.
There's more activity.
Because there's more human activities for the form
It's not the same one.
Any nitrogen oxide, the X means, put a number here, and a 1, and a 2, and a 3, and a 4. Right, which is why there's more NOx in the Northern Hemisphere, which is why the Northern Hemisphere has a smaller hole, because there's more bodyguards to distract the chlorine.
Because you put NOx in the atmosphere?
Right.
And then the bond between, or not water, but the ice crystals and NOx is stronger than NOx and chlorine? Or why does the chlorine leave?
I think the deal with the nitric acid is that precipitates, so it leaves the chlorine region and comes down to the surface. I think we're talking gravity and downdraft there. I don't know about those bond strengths relative to each other. What else? If this part is finished, I can wrap up the unit very quickly now. Sorry, wrap up the assignment very quickly. Remember number 45. Ozone is quickly recovering because we've banned most of the gases. Remember, unfortunately, there may be some new ozone depleters. Just found out a week or two ago. A week ago Monday. And finally, let's do study goal number 46, which is today's warm-up. What are the connections, Gavin, between ozone depletion and climate change? Yes.
I don't know, I was asking you.
There are none. Study goal 46 says, one last thing. Copy this 1,000,000 times. Ozone depletion has nothing to do with climate change or the greenhouse effect. I understand why you would be confused. First of all, they share similar ingredients, like beer and bread. Second of all, I understand why you'd be confused. They both happen in the atmosphere. You know, like surfing and scuba diving. Both happen in the ocean. But these happen in different layers of the atmosphere. There's ozone depletion up there and greenhouse effect down here. Now, coincidentally, Gavin, before the science nerds unite against me, there are two very subtle connections, but it's probably safer to assume none. So look, for every single one of you that would like to pass the AP test, there's no connection. Now for the couple of you that are like truly science nerds and just want to know for the sake of knowing, don't even write this down so you don't confuse yourself later. Technically, more CO2 means more photosynthesis, and more photosynthesis means more oxygen, and more oxygen in the atmosphere means ozone recovers more quickly. Adding CO2 feeds the plants make extra oxygen, so more oxygen means more ozone recovery. That's so subtle, you should just ignore it. There's no relationship. And the opposite relationship is also true. Ozone depletion allows more ultraviolet B to hit the Earth. With more ultraviolet B hitting the Earth, algae dies off. So there's more CO2 left in the atmosphere. So ozone depletion kind of helps climate change. But coincidentally, climate change helps ozone recover. So they probably cancel each other out. And you can totally ignore this. William?
Like, the fact that there's less ozone doesn't allow, like, more sunlight to get to the Earth. And, like,
Not really.
warm things up more.
Not much. Because the difference in ultraviolet emission is so subtle that to whatever degree that probably is a real difference, it's just lost as a feedback loop among much larger feedbacks enforcers.
So the reason we even care about the ozone hole is only because of whatever it was, A, cancer, or no, B, or whatever.
Yeah, basically. I mean, it doesn't just give us cancer. When there's less algae in the ocean, there's less krill. When there's less krill, there's less seafood. So we care about ocean productivity too. And some of us care about leaving less of an impact on the planet. But anyway, no, it's got nothing to do with the scale, order of magnitude human problems with climate change. No, totally separate. Yeah?
Are CFCs and HCFCs considered greenhouse gases?
Yes.
So, and do they trap heat better than carbon dioxide?
Yeah, they do.
So, and a CFC has to do with ozone depletion, right?
Yeah, so they share ingredients like beer and bread. Ozone is also a greenhouse gas. When it's tropospheric, it traps heat. By the way, in the stratosphere, it's too cold to make an impact on temperature. So the ozone layer is not greenhouse effect, but when that gas shows up down low, it is a greenhouse gas. If you're confused by any of that, just remember, no relationship between ozone and climate. It's just a lot easier to do that. We've got, 10 entire minutes, 11 minutes to talk about the life of a handsome